Okay everyone, welcome to our webinar today. My name's Peter Fox and today we'll be joined by Stephen Julian and he's from Western Australia. Together we'll be working through activities for the Australian curriculum using TI Nspire. You there, Stephen? Let me see if I can get Stephen on the line. Hello Stephen, are you there?
Yeah, hello everyone, can you hear me?
Yes, we can. You're coming through loud and clear.
Thanks, Peter.
So, what we're going to do today is talk about our Australian curriculum and in particular our Australian curriculum website. But before we get started, if you're new to the curriculum, TI Nspire or this webinar experience, then we've got a few tips to share with you. Now, let me just bring up some slides that I made earlier. They've disappeared off my computer for the short term. So if you are having trouble hearing us, then there's a sound check that you can do. At the top of the toolbar, there's a communicate menu, and you can use that and make sure the sound on your computer is not muted and that audio broadcast is switched on. Of course, if you are having trouble with the sound, you probably didn't hear what I said, so hopefully you're reading the slide. Again, if you still can't get it to work, you can join us on an audio conference, and that's on our toll-free number, and there's a meeting number there as well. And whilst we're in our webinar, you can also communicate with myself and Stephen through the chat space. You'll see that there's a little green bar at the top of your screen that says Viewing Texas Instruments Desktop. And if you slide over that, then you'll be able to bring up the chat space and send messages to us. Shortly I'll be asking you some questions and you can use that chat space to send your responses to me. Type in your comment and you can send it off to the host. If you have any questions about our products or services, you can call us on that toll-free number if you're in Australia, and also if we have any New Zealand people, which I didn't see any today, you can use that other number. All right, so we're going to get started, and here's my first question, and that is, which number, either 36 or 425, which of those two numbers has the largest number of factors? Okay, so I'm going to give everyone a minute or two to answer that question. You may need more than a minute. You could take a guess. What do you think your students would say to that question, Stephen?
Well, my students would probably get it right because they're obviously very well taught, but probably the most obvious answer would be that the bigger number would have the most factors. They would think that that's always the case, that as you get larger, you'll probably find there are more factors. Some students might get confused by the fact that it's got 5 at the end of the 4,225, so thinking that it's prime, or they may think it's a prime number, so that may mean that they think there's only 2 factors in that number for some of the weaker students. And some students might think, well, 36 is even, so they might work on the fact that there could be a few more factors there. So, but I think the average student would go for the bigger number.
All right, I can see we've had a couple of responses in already. One of those says 36 might have the most number of factors. And look, I'm with you. There's another person who said they think that 36 would. And it's probably a common one because most people know that 36 has quite a few factors. I talk to my students about factor density. There's another one. Gee, I don't know whether these people are seeing each other's answers, but there's a lot coming in at 36. Having the most number of factors. So we're going to explore that shortly and see what the correct answer is. But with my students, I'm not always after what is the correct answer. I'm after their thinking that led to that, which is what Stephen was talking about and referring to even numbers, and most students will pick that even numbers have a lot of factors, and this is a slightly more challenging problem because 4,225 is a pretty big number. And if they pick up that 5 goes into it, they may well pick up 25 will go into it. And already they've found a couple of factors, and therefore they might start drawing conclusions that it's a big number and therefore it'll have a lot of factors. So we'll explore that in just a moment. And of course, when we're starting a unit on factors, And the activity that we're exploring is one called Factors That Count, which I'll show you on the website later. We're looking for a way of determining the quantity of factors, but without actually having to write them down. That's what this investigation is about. Now, don't get me wrong, just because we're using a calculator doesn't mean we're going to do everything on the calculator. The first thing I will get students to do is start with factor trees. And these typically drawn on the board, broken down like that, and there's plenty of textbook exercises that will have their factor trees looking just like that. That was a convenient choice of bringing up the first two factors, 9 and 4. Doesn't always come out that pretty. So students might choose 12 and 3. And the 3 is prime, so therefore we'll continue on factoring from the 12. And just due to the way that the students have done this, the numbers are kind of all over the shop. If we look at that prime factorization, it's really hard to pick up at 3, 2, 2 and 3 because all those numbers are not on the same line. So here's what I actually get students to do. I know that the 3 was redundant. It doesn't need to go any further because it was prime. But if you have a look now at each line of that problem, 12 3s are 36. And notice when I extend down that redundant one, the prime one, I've got 3 times 4 times 3, which still equals 36. And it's really obvious now that all of those numbers are factors of 36. And then it's much clearer with the 3, the 2, the 2 and the 3 across the base of that factor tree. So again, I know that we're bringing in some redundancies there, but I think for the convenience of the clarity that students get from it, that prime factorization, that it's a much better way to do it, and students get a better understanding of it. So, what does all this look like on a calculator? And how does a calculator tackle that kind of thing? So, let me just start a new document. For that, I won't start it here, I'll just start it somewhere else. And we'll have a look at, say, for example, the number menu. And one of the things I always say to students is rather than actually giving them what menu it's in, I say we're working with numbers today and I want to try and factor this number. So I'm using clues from the menus to get the students to look at the actual menu selections. So once I've chosen a number, you can see their option 3 is to factor, something that teachers might often associate with algebra, but works just as well with number. And there we see the prime factorization of 36. So students can compare what the calculator's telling them with what they saw when they're using the factor trees themselves. Now, that works for, say, for example, the other number that we had, and I'll just repeat that menu process again under menu, number, and factor, and we had 4,225, and this was our comparison. Now, it's interesting that it's kind of expressed in a similar way. And as it turns out, and let's list it for those people that are not sure, I create a little program in this other one, and you'll see it's got a little formula there. So I can type in factors, and if I put 36 in there, it tells me it has 9 factors and it lists them for me. This is just an extra thing I put in for this webinar, so if people want this file, I can send it to them. And if I type in 4225, that's nasty, wasn't it? It was a trick question. 4225 also has exactly 9 factors. So, oh, here we go. Someone else has sent in, just after I'd turned around, someone else had said they actually have the same number of factors. So, Pam, you were correct. They both have 9 factors. Which brings me to my next question. If you have a look at the way that number can be expressed, and also factors of 36, or rather the prime factorization of 36, my next question to the audience or to our participants today is, can you figure out another number that would also have exactly 9 factors? So we're looking towards, or working towards solving our problem is, can we come up with a rule whereby we can determine the number of factors without actually writing them down? So if you're still there, Stephen, what would you say about those two answers that we have there? What do they have in common?
I must admit, Peter, I was just sending through a chat to everyone to just say that if you want me to be able to see the chat site, the chat messages coming through, you need to send it to all panellists, not Texas Instruments. So, to be honest with you, Peter, I actually wasn't watching what you were doing there. Sorry. But yeah, just a little hint to everyone, if you can, please, if you want me to be able to see what's going on, we do need all panellists, please. Sorry about that, Peter.
Or even they can send it out to all participants if that's an option for them.
Yeah, that would work as well. Sorry, Peter, I'll get back to paying attention. That's
all right. No, you're fine. You're answering the chat. That's fine. And I've noticed that Alan, one of our participants, has said 100 has exactly 9 factors. Let's see if he's correct. And we'll type in 100. He certainly is. It has 9 factors. Let's have a look at the prime factorization of 100. It's 2 squared by 5 squared. So far we've had 2 squared by 3 squared, and I think the other one was an almighty something like 5 squared times 17 squared, and we've had a 2 squared by 5 squared. Let's see if anyone else can come up with another number that has exactly 9 factors. Let's see how they go. I'm going to throw one in there. Let's and just to let people know while they're figuring that problem out, there's a bit of a clue there. This is off the actual worksheet downloaded from the website. So you can see the questions are selected very carefully. There's a 36, there's 100. Someone might try 196. Someone has sent a smiley face. No, a smiley face does not have 9 factors. I suspect I know who sent the smiley face in. So let's try 196. We'll factor 196. That says 2 squared by 7 squared. And if we try a little factors program, and I wrote this up just so that if anyone sent in some nasty ones, I could check them. And that too has 9 factors. But what was more important was that prime factorization being 2 squared by 7 squared. So, I haven't seen anyone come up with the correct reason why that might be, but I suspect Alan already knows how to work this out because he managed to find another one. And here's another one for people. Factor 441, 3 squared by 7 squared. Remembering every single one of these has 9 factors, and also the fact that they all have an odd number of factors means that these are all perfect squares. So that does narrow it down, but not all perfect squares have 9 factors. So I'm not going to give away the answer as to how you work it out, but just suffice to say, if you try that activity, you will see that it will lead students through with carefully selected questions and instructions, and there's some notes to teachers as well to actually explore. And it calls all that first group, calls them group 1. Then it gets students to investigate another set of numbers. That's the 88, the 104, 875, and so on question 7. And says these all belong to another group of numbers. How many factors do they have? Then eventually, the students are led on to the last part of the investigation and say, look, start trying to tabulate your information. So this is about trying to teach students to problem solve. And we can see the prime factorization of 108 is 2 squared by 3 cubed, and there's 12 factors. The next one is 5 squared by 3 cubed, which, by the way, also has 12 factors, and so does 5 cubed by 3 squared, and 7 squared by 2 cubed. So there's plenty of them that have 12 factors, and it's suggested that the students have a look at this column that refers to the indices and try and work out the rule that relates the number of factors to the prime factorization. So that's that activity. As you can see, it's very, very simple in terms of calculator use. There's nothing complicated about what they're having to do. The other things I just want to show before I pass you across to Stephen to demonstrate an activity from Year 8 is there are other number tools on the menu. So Sounds like we're going out to dinner, doesn't it? So there's least common multiple. Now, the other thing about least common multiple is, depending on what you select the language of when you start your calculator up under the settings, if you set it up in English and UK, terms like greatest common divisor become highest common factor. So the language is localized not just in the menu structure itself, but in the title of the things. So let's have a look at the lowest common multiple, let's say 24 and 36, and we see 72. And that's fairly important if we consider problems such as, let me just use my fraction tool to write this, 1 over 24 plus 1 over 36. There's no coincidence about the 72 being in there. There's also no coincidence that 2 and 3 equals 5, and that may be a little obscure, but teachers can work through that. I use a Venn diagram to illustrate this. But let's have a look at the factors of 72. Prime factorization of 72 is 2 cubed and 3 squared. And if we do the same thing, and this time I'm going to copy and paste just to save time. I'll put 36 in. And if you start to think of the 2 as an A and the 3 as a B, and think about common factors, then we'll actually start to work out why we get a 72. And also, another nice number tool is the greatest common divisor of 24. Oops, and missed my 36. I've got to use a comma, not a decimal place, there it is, as 12, which of course if we factor 12, we get that. And again, students can start to look at the reasons why these numbers are occurring. And that's all about factorizing, but in this case we're using numbers instead of the abstract algebraic representation of a squared and b cubed and so on. So that gives you an idea on how we work through that factors, or factors that count. That's for Year 7, and the National Curriculum Guidelines will show you shortly. But right now, I'm going to transfer across to Stephen so he can share an activity suitable for Year 8. Okay, so I'm sending across to Stephen, and again, just a reminder, if you have any questions, then by all means send them through that chat space.
Okay, thanks, Peter. Now I'm going to look directly at the website, the TI Australian Curriculum Inspire website. Now, pretty much the beauty of this is it's already been set up very nicely for us so that we have everything we need as teachers. So as a teacher, I want easy to use activities. I want reliable activities that I can trust are going to work how I want them to work. I want to have it so that I've got all the resources that I need, so I can feel that I'm not having to spend a lot of time preparing things. I want to make sure that I can modify it in case I feel that there's things I'd like to add for my own class. I'd like to think it's something that's interactive, keeps the students interested, but obviously has educational value, and something I can easily find. Now, what you should be able to see at the moment on my screen is the website main screen. Now, to get into this, if you go into educationti.com and the Australian site, up the top there's a teacher's menu and it says Australian Curriculum Inspired. Now, the one I want to look at today, and it's a very short little activity, not one that I wrote, is in the Year 8 section. And if we go in there, you'll actually get the options of which strands. So I'm going to go over into the measurement strand. I can either choose it from select a strand or in the Year 8 section. So I'm going to look at the measurement and geometry strand. And all these have been linked, as you can see, directly to the Australian curriculum and the correct numbers. And then you'll find that there's all the information you possibly could need. It tells you a little bit about different activities. Over on the right here, you actually have a download. Now, the download will actually allow you to get stuff about, there's things like teachers' resources and sheets. There's the TNS file, which I'll show you in a moment. I'll also show you the handouts. But everything that you could possibly need is on that website, and all you need to do is download it, and you've pretty much got the activity ready to run with your class. So I'll just go out of my web page. Okay, now, if I want to first of all see what kind of things are available for me and the students, the first thing is there's always, with these activities, some kind of student activity sheet. Sometimes it's a PDF, sometimes it's in the form of a Word document. The ones I've contributed are usually in both, but it allows you then to make modifications if you want to. Now, with the handout, you'll notice that it tells you clearly at the top what year group we're working with. It will tell you the aims of the activity, the equipment that you might need. It gives you a little bit of an introduction and tells you what you need to do with the students. And this is the student handout, so it actually tells them where they can find things, how they can open them up and get involved. And then it gives them a little bit of a description about the things that we might be looking at here. So particularly with this one, we're obviously looking at circles. And the main thing that we're trying to work with here is looking at the connections between radius, diameter, circumference and area. So again, it gives them a little bit of a definition, a little bit of information about that. Then, as we scroll down or as we go through the handout, it actually starts talking about the TNS file itself, the actual interactive file that the students can use. Now again, this one's a fairly short little one. The one I'll look at in Year 10 a little bit later is a little bit more in depth. But the first thing it asks the students is, what is the relationship between the radius and the diameter? So if I go into my TNS file, and you'll notice that this would have been already downloaded onto the students' handhelds, so they'd already have this. And it just gives them a little bit of an introduction about radius and diameter. It talks about adjusting the sliders. If the students then move on to the next page, what they'll find here is that they've actually got a little interactive slider screen where they can change the values of the radius and notice what happens with the diameter. So again, very easy little introduction. Hopefully the students already know about the connection, but they can see very quickly that as the radius gets bigger, the diameter is just twice the size. So if the students come back into their handout, what they'll generally find is it'll start taking them through some questions. So this talks about the circumference of the circle, talks a little bit about the connection. It then goes on and talks about how they can adjust their sliders. So again, very interactive, very self-explanatory, so the students can go at their own pace. And then towards the end of this first section, it actually starts talking about where they can record their information. So this also becomes something that they can hand in to you as a teacher, and something that they can use as their own notes. So they've got everything recorded for them. Very easily presented, generally in a language that the students should be able to cope with fairly comfortably at their own pace. So the first section was looking at the connections, so the students can write in their results. The next part, if we go back to the TNS file, looks at the circumference. So it starts getting into, again, the connections, and the students can actually look at from there. So again, go to the next screen. We have a circumference, we have our radius, and at the bottom you'll notice that as I change the slider, the students can see the value of the circumference. So the students again can see straight away that there is some kind of connection, and that's where you can introduce the idea of pi. There are TNS files that actually take you through nicely the connection of the circumference divided by the diameter and gets into that information. So again, if we come back to the students' handout, this one's already gone on to the area. So, sorry, I've just realised I was looking at the circumference, not the diameter, that section. But again, they've got information where they can enter in their circumferences, and then we can move on to the area. So again, as they go, they get to record their information. So again, it talks about the area. It gives them a table that they can fill in and look at the connections. And again, they can come back and have a look at the connections that might be happening here. Record their information with the circumference. Do the same thing for the area. So again, they can adjust the size by using the sliders, get automatic instant feedback. and then come back to their handout and include the information. At the bottom, it gives them some hints. So it actually, again, takes them through if the student can't see the connection straight away. And then it starts talking about some of the things that we might be able to do to the radius. If we double it, how does that affect the circumference, radius, squared, and area? So that would be what the students would get given, the TNS files and the handout. Now, this is the beauty for the teachers, is there are also two other documents that you can get hold of. One is the teacher's notes. So if we go in there, you'll notice that there's quite a few things that have been added, generally in red. It'll tell you exactly the national curriculum statement. So if you are expected by your head of department to give feedback to them about what you're covering. Introduction about the settings, what the students should be careful about with their setups. As we go further down, talks a little bit more again, same type of information the students got, but it also starts giving them information about, for the teacher in case they don't know what the connection is, it actually tells them that the diameter is twice the value of the radius. And that continues through. So all the tables have been filled in, all the information that you could possibly need is already there for you. So you've already got fully worked solutions, or at least solutions that you can work from with the students. And then finally, there's also the student version of all that without the red, but that also includes, as we scroll down, the answers straight away. So it doesn't give the teacher's instructions, but it does give the answers. So if you've got a class that you believe you can trust, or if they've finished the activity, you can then hand this out to them and they can actually work through and check their own work. So they've got everything that they could possibly need, and it's all available to them. And again, that's easily downloadable from the website, and it just goes into your downloads and it's ready to use. So that's the first activity I wanted to look at. As I said, more about what's available on the website than the activity itself. But again, I hope people can see how simple it is to access this, and the fact that these resources are very, very thorough. They actually do have things that the students can use and the teachers can use, and allows the teacher to be able to focus a little bit on helping the students and letting the good students get on with it if they need to, and the weaker students can ask for help as they need to. So that's the first activity I wanted to look at. So I will pass you back to Peter. If I can, sorry, I've just lost that. So I'll pass you back to Peter, who will now look at a Year 9 activity. Thank you, Peter.
Hello, sorry, I might have dropped out of the speaking there. Can you hear me now?
I can hear you, Peter.
All right, sorry. The activity I'm going to demonstrate here is called the Frog Puzzle, and it's also available on the website. Now, in particular reference, Adrian and John Hanna helped write up this Nspired file because it uses some programming, something called Lua programming that happens in the background. So a lot of these more sophisticated files are the ones that we're putting up on the website, stuff that people probably wouldn't ordinarily be able to create themselves. There's some instructions, talks about the object of the game, the fact that frogs cannot hop backwards, although there is one frog that can. I would send that out as a question, but then I suspect people would jump off onto Google and try and find the answer. So I'm not going to throw that out there. You can look that up for yourselves afterwards. So here's the big question, is that there's some sort of a rule that we can use to solve the puzzle. So what's the puzzle all about? Best to see a visual of it. So we start, in this case, I've got two frogs on either side. If I press the menu key, though, you'll notice that we don't get the same menu. All of a sudden we've got this weird menu. So we can change the number of frogs by either increasing, decreasing, or reset the problem, whichever we choose to do. I'm going to start with two frogs on each side, so 4 frogs in total. And if I click on the frog, it moves to the only place it can go, and that's on the lily pad straight in front of it. If I click on this one, and then think, all right, now this one jump, he won't jump because he doesn't have enough energy to jump any more than one frog, and as that lily pad is already occupied, we're out of luck. We can't go anywhere. So therefore, we will need to start the puzzle again. and have another go at it. Now, students can either use a calculator to do this, or they can use coins, dice, whatever manipulatives you want to use as representing the frogs. And this time I'm going to make sure I solve the problem, and I'm just clicking on the frog. And you notice down the bottom left-hand side of the screen, or bottom left corner, that it's actually counting the moves for us. And we're almost done. And therefore, the puzzle with 4 frogs takes 8 moves. We might think that all we've got to do is double the number of frogs and we get the correct number of moves. Of course, if we try that for 3 frogs on each side, we'll find that that rule doesn't work. It's interesting because it would work with 0 frogs and it would work with 4 frogs, but it doesn't work with any other combinations. So, this time, because I know what the instructions ask us to do, they ask us to populate the spreadsheet so that we can start looking at a visual representation of the information that we collect. So we need to record the number of leaps, which is a jump, and the number of creeps, which refers to each time the frog sort of slides forward. So this first one is a creep. This one is a leap. So now I'm going to use a pen to try and record them. So we're up to 1 leap so far. Still only 1 leap. Now we've recorded 2 leaps. 3 leaps. We're almost finished. 1 more. So there were 4 leaps in total. So I can then go onto the spreadsheet, and the number of frogs in this puzzle, as you can see, it jumps up by 2 and then 4. So there's 4 frogs in this puzzle, and it took 4 leaps and 4 creeps. I did warn you I was recording them on a piece of paper. Now, obviously, if there's no frogs on each side, then we would also get 0 leaps and 0 creeps. Now, the interesting part is the way that the file has been set up. It decided it was too trivial just to have 1 frog on each side. So, therefore, the students have to try and figure that one out. They should be able to work that out, that there's actually only 1 leap required. And we'll just go back to our puzzle, and we'll reset it. So imagine we've got this one, we would have 1 leap, and we had 2 creeps. So if we went back into here, we can say we had, was it 2 or 3? I think that was only 2. I'll fix that. Let's just double check that. We'll go back, reset our game. I'm just looking at these middle 2 frogs. So that's 1 creep. There's 2 creeps and 1 leap. So we've now populated the spreadsheet with the first 3 goes. Over here, you notice we could count the number of moves, but instead I'm going to put a formula in. This little grey bar up the top where we see the equal sign, it's a little bit like Excel where you can put a formula in. Now, we could put it in here but and refer to cell B2 plus cell C2 and, oops, not C2, that would be cell B1 and C1 and get 0. And then we could fill that information down. On the software, I can just click and drag. You can also use the menus under Data and Fill. And then we can just arrow down and press Enter, and we can see it starts to populate. The downside is, because the formula only goes to that cell, it won't fill in the formula in cell D4 unless we then put that rule in. We'd have to keep on filling down. There's a much easier way, and I prefer this way in this particular one because it refers to the number of moves. So now I can say, well, the number of moves, and I'm just pressing the variable button, is equal to the number of leaps plus the number of creeps. And it's warning us that we're going to overwrite the stuff we've already done. That's fine. You can see it doesn't look any different at all. But let's have a look when we have 6 frogs in our problem altogether. So we'll go back to our menu, Game, and we'll just increase the number of frogs to 3 on each side. So again, I'll count the number of leaps. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 leaps in that, and 15 moves altogether. So we had 9 leaps. And it's giving us an error over there because it's waiting for us to fill in the rest of the formula. And since it told us there was 15 moves altogether, there must have been 6 creeps. We could go back and check that. Now, by this stage, as maths teachers, most of you are probably looking at that and saying, oh, hang on, there's a pattern there. The number of creeps appears to be equal to the number of frogs. And if we look closely at the number of leaps, 1, 4, 9, so 1 squared, 2 squared, 3 squared. If we halve the number of frogs and square it, we should actually come up with the number of leaps. If students don't leap to that conclusion, sorry about the bad pun, we can also graph it, and you can see that if you actually use the file, it's been set up to start graphing it for you. If I press the tab key, I'll use x as my variable, and we'll have x over 2 squared plus x. And you can see there that so far our line passes straight through all of those points. And to get 4 in a row, we should be reasonably comfortable about predicting what would happen if we lined up some extra frogs. And then, of course, students can go and test that. Number of moves, of course, starts to increase quite quickly. Well, it squares the relationship. So we're going to have a lot of moves just to solve that problem. Now, that's the basic algebra of it. But where the questioning gets to a much higher level is when we question, why does that rule work? And that is a much harder problem for students to work with. But it's a very powerful one because then students having to understand not just the pattern and not just be able to express it, but explain or interpret. Why is there a squared function in there? Why is there a linear function in there? Why is it the total number of moves is the way it is? So let me jump back to the original one. We'll decrease, and then we'll decrease again. And you'll see there is actually a shortcut. You can just hit the negative sign, and that will decrease. If you think about this little character here, he ends up on the other side of the pond, all the way over here. So in total, he actually has to move 1, 2, 3 spaces. And his pal that's sitting behind him will end up in this spot over here. So he too has to move 3 spaces. So the frogs on the left each move 3 spaces, and indeed the frogs on the right move 3 spaces to the left. So if we think about this, that frog has 3 spaces to move, and so does that one. So that's 6 moves in total. And these 2 frogs also have 6 moves in total, which bring us to a total of 12 moves. Let's see how we went on our prediction. 2 frogs on each side, 4 frogs, 8 moves. Let's go back. That's 8 moves, but think about the number of spaces involved. With 8 moves, some of those moves take up 2 shots at a time. So when we leap, this character is actually moving over 2 spaces at a time. So whilst he's got to move a total of 12 spaces altogether in the puzzle, let's go back. Each leap represents 2 lily pads, or 2 spaces. So 2 4s are 8, plus the 4 is 12, so there's a total of 12 spaces that are being moved. It's just that some of them are moving 2 at a time. And then if we go back again to the puzzle, let me just reset him. Think about the number of leaps that we need to take. This frog has to get past that one, and the only way to do that is a leap. This frog has to get past the other one, and the only way he can do that is to leap. In fact, this frog has 2 frogs to leap, in which case that's 2 leaps that must take place, whether it's the one on the right jumping the one on the left or vice versa. To get to the other side, this one must do 2 leaps or be leapt twice. Same with this. So 2 lots of 2 is 4, so we get 4 leaps. and each leap is 2 lily pads. That gives us a total of 8 spaces. We decided before we've got 12 spaces to move altogether, which leaves us with 4 creep forward. That's a lot to take in, and that's where diagrams are very useful, and any student that tries to describe that whole scenario without a diagram would be working pretty hard. So let's just review it with 3 frogs on each side. That frog there that I'm pointing to, he has 3 frogs to leap over, so does the one behind him and the one behind him. So that's a total of 9 leaps that need to take place. Each leap represents 2 spaces, so that's 18 spaces altogether. We worked out before how many spaces were required. This frog is going to move 4 spaces to get to the other end, so is each one of those. So that's a total of 3 lots of 4, that's 12, plus these are going to do the same, so that's 24 spaces, and we've worked out how many spaces we move. Each time we jump, there was 9 jumps and 9 leaps. That's 18 spaces, leaving us with 6 creeps. There's a lot to take in. You might want to listen to the recording afterwards. Hopefully I didn't jumble over it. And there's our 6 creeps. So we can actually work out, using this pattern, a rule, but not just the rule, reason or understand that rule. So that one is our frog puzzle. That one's in the Year 9 activities. And I'm now going to pass it back to Stephen, who's going to demonstrate an activity in the national curriculum for our Year 10 students. Are you there, Stephen?
Yes, I am, Peter. Thank you.
All right, so I'm just going to send the presentation back to you, and you can demonstrate a Year 10 activity.
Okay, thank you, Peter. Obviously, as teachers, and as we become more familiar with the new curriculum, the new Australian curriculum, and as more people contribute to the website, more activities will become available. So at the moment, there are some really good activities on there, but again, as people are willing to give more, and as people like Peter and myself and so on actually start making more of these activities, hopefully you'll find that the resource grows very, very quickly. And so hopefully people do feel comfortable with actually sharing their ideas as well. So one of the ones I'm about to show you is my second activity, which is actually something I've written but hasn't quite made it yet onto the website. It will be available shortly, I hope. So this is a bit of a world first exclusive for everyone out there. And so what this one's going to involve looking at is looking at the ways that areas of triangles can be actually worked out. Something that sometimes students can find a little bit tricky to see the connection between a half base times height, and obviously the one we use with our more senior students, which is the half AB sine C rule. So this little file and the activities that go with it will actually take you through and show you how it's all connected. With this file, I've actually written it in a way that makes it so that, again, the students are very self-sufficient. So hopefully students can work at their own pace, and you're there to talk them through things, but also to make it available to them that you can help out the students who are having more trouble. So where do we find these things again? Again, back on the Australian Curriculum Inspired website. This one I will assume will end up in the Year 10A one, because it's a little bit more complex than the basic Year 10. And again, it will have all the usual documents that I showed you earlier. So the idea, and I'll take you through this very quickly because I know we have limited time, but Jack has got a problem about trying to find the area of a tile. He's trying to find the area of it. So he can go in and we can see that Jack's got his tile. It gives you the information already. It talks about how we've learnt already about half base times height, but what about non-right angle triangles? So again, you can see pretty much talks the students through, tells them what rules they should already know, and down the bottom here it says we're going to go in and have a look at a couple of triangles in a moment, and we're going to press Control followed by the dot, full stop, or decimal point, which will actually capture some of the results that we get with these triangles. So I'll show you how that works in a moment. It then talks about repeating the process for 5 different triangles. and then the students have to fill in the information on the worksheet. Okay, so we have this triangle. It has different information, very random. If we go into 1.8, you'll notice at the moment that there is no information there at all. It's a totally blank spreadsheet, and this has already been set up for the students and yourself. So going back to 1.7, I might just move this triangle around a little bit by just grabbing one of the vertices. And then I'm going to go Control and full stop, and you'll notice above the full stop key, there's the word capture. So what that's done is actually captured that live screen. So if we go back into the 1.8, you'll now find that it's got the base, the height, and the area. And it's recorded that information based on a half base times height. If I go back in to 1.7, drag the triangle around, make it something totally different, Control, decimal point. If we go back in, you'll notice that it's now recorded the second area. Now, the students are asked to do 5 of those. I won't do that here now. But what they can do is, again, there'll be an activity sheet available. This one's actually set up as just a Word document at the moment. So the students can look at this and go through. Again, it gives them all information about the file, like I mentioned earlier. Talks about the introductory screen. It gives them a bit of an introduction. And then it outlines to the students exactly what they need to be doing. So rather than having to jump between screens if they forget what they have to push, it's already provided for them on this handout. It then talks about that they need to record their information, so viewing the results, and down at the bottom it says record the information in question 1. So later in the table, or in the handout, there's actually a table and the students have space for them to record everything. It then talks about how those values could have been worked out, and the students are encouraged to try a half base times height with the base and height from their table and check that their areas are correct. And again, they can use a scratch pad or other ways of doing that to get the right answer. Okay. Then they can move on and start looking at, well, what happens if it's not a right angle, a triangle that has a base and a height? So what about if it's something that might have 2 sides and an angle? So again, students can go through, have a look at the information that's provided to them. It talks about this half A times B times sine theta rule. Again, the students are given a triangle, which was back here on the 1.7. And what you'll notice is if I now scroll through and look at the areas for this, and then go through, the students are getting the same area, but again using different information to get the same areas. So what this is confirming for the students is that there's different ways of working out the area of a triangle. They don't have to just use a half base times height. Now once they've got that information, again the students can come into their handout. There's information up higher, and then there's a table for them to record the information. It talks about the rule, and then it takes them through and asks them to actually calculate it. So again, the students are not just relying on the technology, the mathematics side of things is also being enforced. So it's really encouraging them not just to rely on what they're being shown. They're actually expected to then see that there's a mathematical importance to what they're doing as well.
If I can just add to what Stephen's doing there, a couple of things that really jump out is that if teachers are correcting students' work and having a look at their responses, every student ends up with a different set of values for their side A and side B. If they don't, you pretty much know they're copying because the probability of them generating exactly the same values would be near enough to a 0 probability. And the other thing, of course, is as Stephen said, it's being reinforced. They're writing the stuff down by hand, but the use of the dynamic geometry, I've done activities sort of similar to this by hand, and they're not as convincing because when the student tries to measure the angle by hand, it's so easy for them to be out by 1 degree, and then they miss the point entirely. The area of the triangle doesn't end up the same. They see it as approximate, and therefore having the dynamic geometry and getting that area the same, at least a couple of decimal places, the students are much happier to say, yeah, that's the same area.
Thanks, Peter. Yeah, exactly right. And that's something I've found using this activity with my own students, that I know whether they're copying or not. It's very, very obvious very, very quickly. Okay, the next thing, again, the TNS file takes you through, and it just talks about checking your answers using your rule, etc., etc. It just reminds them about using degree mode, just in case they're getting weird-looking answers. And then it talks about trying the 4 extra triangles that are included with the worksheet. It now goes on and asks them to work out the information for Jack's tile. Now, this is the part that I always like to reinforce to students, is that there's a reason, there's mathematics behind why we're doing this. So we've now seen that this works and it gives you the right answer. But now, and again, the handout takes you through and explains to the students what they need to be doing. It actually talks about, well, why does this rule work? So there's a little interactive thing where they can grab the green triangle and actually move it and separate it into 2 triangles. So they can see that, okay, this triangle, it's not necessarily something that has a height and a base. It could be an A and a B and an angle. But they can actually separate it into 2 different triangles by just grabbing it. Moving on to the next page, it then starts talking about the idea of, is there a connection? So we can look at the blue triangle and start saying, well, what do we know about the angle, the A and the H? And hopefully students start seeing, well, theta, opposite, hypotenuse. The height is actually our opposite side here. And they can see that this is a right angle triangle, and they can work with the idea of our trig functions and sine. It then says, well, let's go back to our handout. Sorry, people, I've just got to minimise something here. Okay, so if we go back to our student handout, again, the students are actually taken through that above, and then there's a place here where they can do their working out, something to do with Jack's original tile, and then there's information about where they can put down their rearrangements and looking at the connections, and it gives all the information for the students to hopefully be able to explore and see the connection between area equals a half base times height and the rule that we've just worked out of a half AB times sine theta. Now, like previously, as I mentioned earlier, there's also a teacher's answer version of this. So again, this is the one that the students could have if they wanted, with all the solutions written in. And again, we'll talk about varying answers like Peter mentioned before. And there's also a teacher's notes version that will be available, and that's the circle one. Sorry, I pulled up the wrong one there.
And just to let people know, the difference between the teacher, or the answers, and the teacher notes, we provide tips. So say, for example, if I put down the answers for that factor one, then you could just say, oh, that's great, that's some magical mystery formula. But the teacher notes say, they'll give some clues, I guess, some prompts that you can also give students that are getting close but haven't quite got there yet. So it includes some subtle hints and suggests maybe give the students another group of numbers if they haven't quite got it yet. So based on the experience of people that have done these activities before, the sorts of things that they've used, we put those or add those into the teacher notes.
Yep, and that's the thing I've just brought up here. So this is now the teacher's notes version. So unlike the answers, which just gives the answers for the teacher and the students, this actually now goes in and talks about the correct national curriculum statement and the number. So again, if you have to report back to your head of department, all the information is included. It talks about, again, some specific things for the teachers to know about downloading. And again, I won't scroll through the whole thing, but you can see that it talks about students should get different results. So just to highlight the fact that you're not looking for the same answer for certain things. So hopefully very easy to use, very direct for the teacher, and gives them all the information that they need. So that's the area of the triangle activity. Just one other plug I was going to put in as well, I was going to mention, is obviously we've got this Australian National Curriculum Inspired site, but also the YouTube, the TI Australian YouTube channel. There's a lot of great stuff on there in terms of ready-made things to be looking at, how-to clips, stuff that can actually make it so that you, again, don't have to necessarily be contacting people all the time. There's suggested activities, things that you might find of use to use with your students. And some of the things on the YouTube channel are directed directly to the students, others are to the teachers. So there's a lot of other things that are available if you're willing to go out and search. So that was the The Australian TI YouTube site, if you go into YouTube and type TI Australia, it's very easy to find and very easy to navigate through. So on that note, that's my activity. I know we're nearly out of time, so I'll pass you back to Peter.
Thanks, Stephen. And just while I'm sharing my desktop, I will take people in to show them that area very briefly. So just while my screen's coming up, when you go onto the website, a lot of people just end up on the US website. You can see the Australian website. We've actually got the Harbour Bridge included in it. Have a look in the right-hand corner. It will say Site, Australia and New Zealand. And to change where you're located, you can click on that site and select your region. Then the simplest thing is just add that to your favourites. What I've done here is we've added on a whole teacher section to make it easier for teachers coming into our website. So if you're not looking for specific product content, you're looking for activities, support, resources, volume purchase program, all of those sorts of information are sitting in this space here, a section dedicated just for teachers to look for activities and so on. So we've got an activities section, we've got professional development and teacher resources. Under professional development, you'll find that we have links to our webinars, TCube workshops. We have a whole program for teachers where they can come along to a workshop. We're also at conferences as well. There's a link to our major conference, which if you're really quick, you could fly over to the US and attend that one. A couple of thousand teachers go along there. There's a link to our YouTube channel that Stephen was referring to. Atomic Learning is another good site which we link off to that contains step-by-step tutorials. And don't just, I know we've actually got that in our teacher section, but students can also go to that space as well. So that's our teacher section. I'm going to jump straight onto the Australian curriculum website that Stephen was on before. And here's and this you might be familiar with, it was on our opening page. But let's suppose I went on to Year 10, I've got a Year 10 class, and let's say I've got a particular standard in mind. Then I can go down to here and choose my standard that I'm looking for. I'm going to choose this one on number and algebra, and this is going to become more populated as we go through the year. This is only something we've set up late last year. So here I've got one on growing interest, and it tells you the actual standard over here. I can change it and have a look for other standards. Let me jump on to another one. Here's one on parallel and perpendicular lines. Now, in this case, this one's actually an assessment. It says down here, electronic auto-correcting assessment. Well, that's if you've got TI Navigator. You can still send these questions out to students. On the right-hand side, you'll see you can download the whole lot as a zip file. You can download the TI Nspire file. That's got the answers built into it. So if you're using TI Navigator, you can send that out, and the Navigator system will mark it all for you. On the other hand, for those teachers that are not even using Nspire but just interested in what's going on or want to do some assessments, I'm opening up that PDF at the moment, and you're allowed to photocopy these questions and hand them out to your students and collect them. They're basically just a simple test, and these are exactly the same questions that come up in the Nspire file. So we've duplicated them. So the first one you see, which one of the following is parallel to the line with equation 2x plus 3? These tests are free. You can download them, photocopy them, and give them to students. They're just a one page, two sides, and we also include the answers just in case you didn't want to work them out for yourselves. So again, free resource, all on our website. We're out of time now. I see from my clock on my computer it says that it's 4:59 here in Melbourne. So we're out of time. We've got to finish at 5. Thanks, everyone, for coming along to our webinar, and we hope to see you again very soon for our next webinar. Thank you.